All right, we're going to get started right in with lesson 7. This is on page 80 in your book, so go ahead and get there if you aren't already there. And begin writing these goals at the top of your paper. So our first goal is we're going to be matching the correlation coefficient to its correct scatter plot and linear model. Okay, so I have highlighted that word because it is a new vocab word for this lesson. We're going to use that correlation coefficient to determine the goodness of the line of best fit. So once again, just like our residuals that we did in lesson 6, this is just another method. This is another way to determine whether our line of best fit is going to give us a very accurate representation of the rest of the data that we collected. Okay. So like the residuals, the further it was, the actual data was from the line of best fit, the less accurate it is. Okay. So we're going to be continuing that idea today and talking about correlation coefficients. Okay. So the first thing we have here are these 4 graphs. Okay, so that you have them all on your paper. I just want you, it says which one doesn't belong, and you're supposed to choose one, but instead what I want you to do is I want you to just make some just bullet point observations about each graph, okay? So just, it can be very obvious observations too, okay? But I'm gonna give you about 2 minutes and I want you to just give me about 2 bullet points per graph, okay? And then we will talk about it together, okay? So I'm setting a timer for 2 minutes. Ready, go. Please do not just sit there and please do not fast forward either. Really write it down. Go. All right, so let's just go ahead and start writing these out. Obviously, I can't see what y'all wrote, but if y'all have similar observations to mine, then that's great. So for part A, I realize this looks like the only graph out of all of them that is increasing at a constant rate. Okay, so so it's the only one. Whoops. That has a line that at a pretty constant rate. Not exactly constant because it is a little scattered. It also looks like the data is close together, right? It's not all spread out. Okay, so AKA, another word we could use for this is that it's very linear. you didn't write anything else down, make sure you put that it's very linear because it looks like it forms a pretty good line. All right, so B, this one is the data is random, spread out, however you worded it like that. It doesn't look like it's increasing or increasing. Okay, so this is what we would call a non-linear. Okay, it doesn't form a line, so that makes sense, right? Linear means it forms a line, non-linear doesn't look like it forms any line. Okay, so make sure you have something like that down for it. All right, so this one, we can see the data is decreasing. Okay, it looks to be more linear, just like we talked about in the other one. See, it's because it's pretty close together and clustered together. All right, and then finally, this one doesn't form a line, but the data is close together. It looks like data, you know, it's clustered together. It is increasing. Okay, it's a little different. It's not linear because it curves. All right, so all good things. We're going to continue looking at these scatter plots and talking about what it means when it is more clustered together, when it is more spread out, when it is increasing, when it's decreasing as we move forward in this next section. So if you look at your next page, I don't know if you have to turn or not, but 7.2 is a card sort. It says your teacher will give you a set of cards that show scatter plots of data. Sort the cards into 2 categories of your choosing. Be prepared to explain the meaning of your categories. Then sort the cards into 2 categories in a different way. Be prepared to explain the meaning of your new categories. Okay, so you do not have these in your book, and because of guidelines and stuff, I can't, give you cards to sort out like I normally would. I can't let you work in groups. So we're going to do it the best we can. And you're just going to look at this screen. Okay. They are kind of tiny. I know that you may have to, enlarge my little video on your screen and actually, try to do it, but you don't have to. I mean, they're all scaled pretty similarly, except for this eye. All of them are pretty scaled low, and they're none of the axes are labeled. We're just looking at how spread out the data and stuff is. Okay. So I just want you to make a couple of observations. These are only in order. They're in alphabetical order. So A, B, C, D, E, F, G, H, I, J, okay, are all over here. So I want you to look and maybe come up with 2 categories, okay, based on maybe what we talked about in the little first section, and group each of the data up. And then if you can, come up with a second 2 categories and group them. Okay, so you could group them by the data being really close together and really spread out and then sort them. You can group them by being increasing and decreasing, whatever you think. Okay, I've given you 2 really good hints there. All right, and then we will talk about it. Okay, I'm going to give you about 2 minutes to do that. Ready? Please actually do it, guys. Actually think it through, because if you don't do this activity, then it's going to be really hard to move forward and talk about the next one. Okay, ready? 2 minutes, go. You have about 45 seconds left. Please be thinking of good categories so that we can talk about it. Okay, so I kind of gave y'all some ideas of how you could have chosen to group your data. So one of the ways you could have done it was by data that was really clustered together in linear and data that was not. Okay, so this looks like it's non-linear. This looks pretty non-linear. This one looks more linear because you can tell it's decreasing. That's linear, non-linear, linear, linear, non-linear. This one wouldn't be considered linear because it curves, but it is pretty clustered together. All right, so that's one way you could have looked at it. Another way is you could have done it by all the ones that are increasing and decreasing. So while this one doesn't really form a good line, you can tell that overall it looks like they are decreasing. This one, you can't tell. That one's decreasing. This one looks like it's mostly increasing, increasing, increasing. Can't tell. Increasing and decreasing. Okay. Any way you wanted to do it, you could have done it. And obviously there's some where it's just like hard to tell. Oh, this is decreasing. I forgot. I skipped that one. Okay. Now, what I want y'all to do is I want you to look at these graphs with a little bit of information about them. So I have them all down here, and with them I have their equations for their lines of best fit. So now you can see the line of best fit going through each one of the graphs that we just looked at, A through J. And then it gives us another piece of information. It gives us this R. And now I do not want you to confuse this R value with a residual. Okay, this R value actually represents the correlation coefficient. So now that we have these lines of best fit in there, okay, you can see them going through our data. Well, this number tells us something important about the line of best fit. Okay, so I'm going to give you a minute or so. I want you to look through all of those lines. I want you to look and see, okay, are these lines good? Are they bad? Whatever. And I want you to then compare them to whatever the correlation coefficient or the R value is. All right, and see if you can make any observations about those two things. And then we're going to make some observations together. So I'm going to give you about a minute and see if you can make any connections on your own. And you don't have to write anything down, just like think them in your head. And then we will go over them together and write some stuff down in that spot in your book. 1 minute, ready, go. Okay, so in your book on 7.2, I know there's not a lot of space, but we're going to make some observations about these things. Okay, so these R values are the correlation coefficient. So write this down. Let me spell this right. And this is just another way to measure the strength of a linear relationship. All right. So hopefully maybe some of y'all noticed that for problems like G, we can see that that line of best fit goes directly through all of those data points, okay? And even I is really, really close. J is pretty close to the line of best fit, okay? D is exactly on the line again. So D and G, they're both on the line and their R values are both 1. Now one's positive and one's negative. So why do you think this one's positive and that one's negative? Okay. The correlation coefficient is directly related also to its slope and how close the data points are to the line of best fit. So one thing that you can write down here is the sign of the R value is the same as the sign of the slope. Okay, so if your slope is positive, your R value will be positive. If your slope is negative, your R value will be negative. Also, something that you need to know is that R values go from -1 to +1. You can see that in all of these here. Okay, they all stay within that range. Now, what do those mean? Okay, the closer the R value is to 1 or -1, the stronger the correlation. Okay, so just like I said in G and D, those lines went straight through the data and our R values were 1 and -1. +1 because it's a positive slope, -1 because it's a negative slope. But since they are right on the line, it has an extremely strong correlation, okay, because it's closer to 1 or -1. All right. And so then on the opposite side, oops, the closer the R value is to 0, the weaker the correlation. All right, and you can see that in H. We said that that was super nonlinear earlier in our observations. It's all really spread out. And now that the line's going through it, it's really spread out. And look at its R value. Okay, generally it says that it's decreasing because our slope is negative here. But it's 0.13, which is really close to 0. So it has a really weak correlation. All right, another one right here. That's the one we said that was really nonlinear earlier. Okay, even though that line's going through it and it is decreasing, it's very far spread out from our line of best fit. So it has it's a negative and weak correlation. Okay, another one is right here. Anything below like 0.7 is probably a pretty weak correlation, okay? So this one is 0.46, which you would think, okay, that's halfway. But no, it's really not. It's closer to 0, so it has a weaker correlation. Okay, so get all of these little points, No, it's a lot, but you'll need it for the next section. Pause the video and get all of those written down because you will need them for the rest of your notes. Okay, so that brings us to 7.3. It says take turns with your partner to match the scatter plot with the correlation coefficient, okay? You're not going to have a partner. You're just doing this on your own. But remember that correlation coefficient is the R value. It says for each match you find, explain to your partner how you know it's true. Obviously, you're not going to do that. And for each match, you're basically just matching them, okay? You can't do all the other steps. Okay, so here's all of our R values. We know that the closer it is to 1 or -1, the stronger. Okay, we know that if it's positive or negative, that is directly related to whatever its slope is. Okay, and then the closer it is to 0, that means it's weaker, has a weaker correlation. That means it's more spread out. Okay, so let's look at this first one together. Okay, so not only, first thing I notice is that it's increasing. Okay, so since the slope is increasing, I know that my R value is going to be positive. Okay, so I can mark off this one, this one, this one, this, oh, just kidding. Mark off those 3 and that one. Okay, so it's going to be 8, or oh my gosh, 5, 6, 7, or 8. All right, the next thing I notice is that they are all exactly on the line. Okay, so since all of my values are exactly on the line, it has to have the strongest correlation. So the only option that I have is 8. So it would be A. Okay, so you're going to do that with the rest of the graphs that are on the next couple of pages. So you're just going to have to flip back and forth and do all of those. And then I'm going to give you all a couple of minutes and then we will talk about them together. I'll give you about 2 minutes. And if you need more time, then just pause the video and do it. Okay. This is not too hard. So please take your time and try on it. Okay. So I'm going to give you 2 minutes. Ready, go. You'll have about 15 seconds left. If you need to pause the video, you go for it. Okay, so these are the answers that you should have gotten for this. For number 1, you should have gotten F, 2, C, 3, D, 4, G, 5, H, 6, E, 7, B. Okay, those are the answers for the correlation coefficient. That shows you exactly how strong the relationship is from the line and the data values. So once again, the correlation coefficient is a way to qualify the strength of the linear relationship. Very similar to residuals, but not to be confused with each other, okay? Residuals are completely different. It says, what does the sign of the correlation tell you about the data? Now, this question is not in your book. I'm just asking. And we know that the sign tells you whether the slope is positive or negative, whether the data is increasing or decreasing. And it says, what does it mean to have a correlation coefficient of 1 or -1? And we know that that means it's very, very strong relationship. It's very, very close to your line. All right. And then that brings us to the lesson summary, which is on page 88. So go ahead and turn there in your book. If I can find it. There we are. This is page 88. All right. So it says, while residuals can help pick the best line to fit the data among all the lines, we still need a way to determine the strength of the line. Okay. Scatter plots of data that are close to the best fit line are better modeled by the line than the scatter plots of data that are farther from the line. The correlation coefficient is a convenient number that can be used to describe the strength and direction of a linear relationship. Okay, so there is that vocab word. It says right here, the letter R for the correlation coefficient can take values from -1 to 1. And then the last sentence, when the correlation coefficient is closer to 1 or -1, the linear model fits the data better. Okay, so it gives us a bunch of different values here, and it gives us all of their R values with them. Says, while it is possible to try to fit a linear model to any data, you should always look at the scatter plot to see if there's a possible linear trend. The correlation coefficient and residuals can also help determine whether the linear model makes sense to use to estimate the situation. In some cases, another type of function might be a better fit for the data, or the two variables you're examining may be uncorrelated. You should look for other connections using other variables. All right, so that is it for lesson 7.